In the previous case, what you saw that if you have some high massive isotope is substituted, it is being put there, then you get still equispace spectral lines slightly left to the rigidodal lines. But in this case, the spectral lines are also non-equispaced, isn't it? And the gap, successive lines, the gap between two successive lines would get decreased if you go for higher and higher J values. Okay. Now, we will see, let's say I'll do it with this. So because what you need when you try to understand any spectral characteristic, you need to know two important characteristics. One is the spectral line position, another is the line intensity. Okay, so line position, you can see that we have some derivations. So if we know from quantum mechanics, we can, in principle, say, solve the corresponding Schrodinger equation and get the energy levels. And then we apply the corresponding selection rules and see whether the globe, say, whether the corresponding transition is allowed or not. So we have to treat the cross selection rule first. And then for a given initial state, what are the final states we can go to after transition, that you can follow using the specific selection rules. After doing this, you can get the line positions. And remember that actual experimental line positions may not be exactly the same as what you would have expected, because you are talking about a model. Okay. Like as you can see that if you apply rigid rotor model, you get one picture. If you apply non-rigid rotor, you'll get another picture. But if you do the spectroscopic experiment in a spectrophotometer, obviously you get only one type of, say, spectral pattern. One spectrum you will get. Okay. For a given molecule, given transition, you will get only one spectrum. So now you can see in certain cases, maybe non-rigidity is not that important. In some cases, you cannot explain using only a rigid rotor model. So that is the actual hallmark that you have to judge when it is required, when it is not, when the model also can give you reasonably, say, acceptable results. Okay. Now, in this case, another important thing you have to know is the line intensity. As I told you before, line intensity changes. So there are several aspects how the line intensities change. The first, I told you about the change in the line intensities. So suppose if some of the lines, they are having almost negligible intensity so that you cannot see it with your eyes. Then what will happen? Suppose if this one is not there, either completely not there or it is so feeble that you cannot see it. Then you will consider this as your first one and this as your second one, because this you cannot see and you will get a wrong result. So you have to know the line intensity also. There may be broadening. Some of the lines may not appear at all, or they are having so poor intensity you cannot see them. That may have the actual quantum mechanical reason, or that may be because of something else, and that we will see what is that something else. We will see some other aspects also later. Say, we'll talk about the energy levels. First, let's say I'll talk about the digit router. You can always apply it to non-digit router. There is no trouble. So, and you have